Okay, so we're going to try these three practice problems in practice part 1. I want you to try all these problems on your own before you watch this part of the video to see if you've got the steps. Either pause the video or hopefully you haven't even started it until you've tried these, and press play when you want to either check your answer or you want to, if you get stuck and you need some help. So here we go. Problem A. Again, I can tell it's a trig equation. I can see because I have a variable inside the trig. I'm taking the cosine of some angle. Let me zoom in a little bit, make this bigger for you. And so I need to first isolate the trig, and to do that I'm going to divide both sides by 2. I'm left with the cosine of some angle x equals negative radical 2 over 2. I'll go up to my my unit circle here. Again, I'm looking, you can write it this way if you want. I want the inverse cosine of negative radical 2 over 2. Both of these ways are indicating I want some angle that has a cosine of negative radical 2 over 2. As we look up here, we'll see that that happens at both 3 pi over 4 would have a cosine of negative radical 2 over 2, as would 5 pi over 4. Those are the two places we're looking for this problem. And so we're going to write x equals 3 pi over 4 and x equals 5 pi over 4. But the fact that this was looking for all solutions, and I even gave you a hint, also known as the general solution, I'm going to want to write plus 2 pi n for both of these, because not just the initial angle, but any angle that is coterminal with it or 360 degrees past it will also have a cosine of negative radical 2 over 2. So these are the answers for problem A. Alright, in problem B we're looking for the solutions on the interval 0 to 2 pi. But first let's go ahead and isolate the trig again. So we'll go 12 sine of x equals negative 6. Therefore the sine of x equals negative 1/2. And actually we're back to the very first problem we did, where we're looking for some x that's the inverse sine of negative 1/2, some angle that has a sine of negative 1/2. That happens at 7 pi over 6 and 11 pi over 6. And we don't have to put the plus 2 pi in here because we're looking only for the solutions on the interval 0 to 2 pi. So these are the two values of x, the two values of angles that would make this true. Okay, one last example. Same thing, we're looking for solutions on the interval 0 to 2 pi. Let's isolate the trig first. So I've got the tangent of x equals 0. So I'm looking for some angle that has a tangent of 0. And I know that happens at, well, where does that happen? Let's think about it. I need somewhere where the opposite is 0 and the adjacent is not 0. So that will happen both here at 0 pi and then over here at 1 pi. And it'll happen again at 2 pi as well, and then 3 pi, and then forever on and on. Every pi, so 0, and then every pi after that, so 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, all of those have tangents equal to 0 because we put the opposite side 0 over the adjacent side 1, or in this case negative 1, and we still get a tangent equal to 0. So my best solution would be to say 0 pi and pi. Now it says all solutions on the interval 0 with a bracket to 2 pi. So yes, 2 pi does have a tangent equal to 0, but it's not on this interval, so I'm going to cross it off. I just want the answer 0 pi and 1 pi. That solves problem C.